Hey, coming up on This Week in Radio Tech, Paul Kriegler is our guest. He's an expert at audio processing. The guy is so modest, but he knows exactly what he's talking about. He's made a lot of stations sound fantastic. So we've got information on that, podcasting, and AES 192, all with me, Chris, and Paul Kriegler on TWiRT. This Week in Radio Tech is brought to you by Broadcasters General Store, with outstanding service, saving, and support. Online at bgs.cc. By the new Ruby console from Lavo. See Lavo in your future at lavo.com/TWiRT. And by the Telos Alliance, shaping the future of audio, inspiring you to create the most exciting and engaging audio experiences imaginable. Visit telosalliance.com/opt-in. Hey, welcome into This Week in Radio Tech. I'm Kirk Harnack, your host. Delighted to be here. I'm not in the usual office. I'm in the mountain bunker here. This Week in Radio Tech. Got a nice view of the mountains. I can see North Carolina from here. I actually can't. So, well, the sun will go down and I'll miss it, and then I'll just go get in the hot tub after the after the show's over. So this is the show where we talk about everything from the microphone to the light bulb at the top of the tower. And today we're going to be talking about something very important in between. In fact, it's what a lot of people say just makes the sound of the whole radio station. Audio processing is our topic, but maybe not what you think. We've got a few interesting side topics about audio processing and audio cleanliness to talk about. We've brought in Paul Kriegler to talk about that. I'll introduce him in just a minute. First, I want to bring in my co-host. He's here almost every week. It's Chris Tobin at some undisclosed studio in the New York area. Hey, Chris, welcome in.
Hello, Kirk. Yeah, I'm just in the usual little news production studio, and something very straightforward, nothing crazy. No bunker status, not looking over on a mountain range or a valley or the sun setting, and a nice rustic scene. It's basically four walls treated with fabric and deadened for sound. So yes, I could probably scream for help and you'd hear me.
Well, I'm usually when I am broadcasting from this location, there is a whole family here with me, and I got to tell them to be quiet because the walls are thin, the floors are not heavy duty, not soundproof, and I got to remind the kid, hey, don't run around in the living room. Well, today I got here first. I'm in the living room. And so it's going to be nice and quiet here, unless the phone rings or something like that. So we're gonna have a good show here with Chris in New York, Kirk in Gatlinburg. I might as well say Gatlinburg. I'm outside of Gatlinburg, but I'm in the Smoky Mountains. And our guest is here, Paul Kriegler from Austin, Texas, home of the cool dudes. Hey, Paul, welcome into This Week in Radio Tech.
Dazed and confused on this week's TWiRT. Happy to be here, Kirk. Thanks.
For those who don't know, Paul is one of my colleagues now. Paul works with me at the Telos Alliance. And that's a little bit of why he's on the show. But he's one of the people who I know who has a lot to say about audio processing. And hey, Paul, give us a little elevator speech on your prior experience to joining the Telos Alliance and doing a lot of audio processing. What did you do? What qualifies you for audio processing?
Well, Kirk, I was in programming for about 30 years and worked with a lot of engineers at different stations that I've been at over the years. I've been in markets like Phoenix, Atlanta, Kansas City, spent a lot of time in Tulsa. My last job in radio was working for the Lotus Group in Reno, Nevada. And that's where I came in contact with the folks from Telos a couple years ago, and they hired me just last year, and it's a great company. But I first started with a pirate station in my dad's basement, and I always wondered why my pirate station didn't sound as good as the other Omaha stations in the market, like Sweet 98 or Z92. Why wasn't my station as loud as Z92? And when I finally saw what they had in their air chain and learned about what processing was through, having a part-time job at one of the NPR stations in Omaha growing up, that's when I kind of learned, that's where my interest came at a very early age when it came to processing.
How neat is that? Chris, that sounds a lot like Corny's story. Corny's been with us and told us about how he got started with the pirate radio station and noticed, my station doesn't sound as good as the others. I wonder why that is.
I think there's many people, many audience members who can relate to that as a background of learning, whether it be audio processing in that particular line of unlicensed operation, or maybe transmitter design or studio design, combination of all of those. I've met many folks who've told me that they started out in that same fashion.
Yeah, it's just funny how you go from, it's funny how you go from, I'm on the air, but you can't be happy enough with that. No, you got to be louder.
Yeah,
True.
I know. Well, yeah, and we know historically there is some benefit to being louder as long as you're not stupid about it. So we want to help people not be stupid. We want to help them achieve loudness and more importantly consistency. And tell you what, let's hear from our first sponsor, and then we're going to talk on this show a lot about audio processing for FM and not just the tweaking of the processor, because Paul can tell us about that, but we're also going to talk about some of the new ways to connect processors and transmitters, and how I didn't realize what an advantage this was. I guess I kind of thought about it, but Paul really brought this home in a conversation that he and I had a week or so ago. We'll talk about this. Technology is available right now. You can, and maybe you already have it and don't know it, or maybe you can just change one piece and get this tech. But we got a lot of subjects to cover. But right now, I want to talk about my friends at the Telos Alliance and the audio processing that they do for streaming. Now, a few months ago, I got really interested in finding out how to best process audio for smart speakers. The smart speaker listening market continues to grow. It's still small, but it grows by leaps and bounds. And when you're small, leaps and bounds, make a difference. But I think in the future, a lot of our listeners listening will be done on smart speakers. I know at the Harnack House, when we want to listen to a radio station, I got to tell you, I mean, maybe we're just lazy, but we don't tune in the radio so often. In the car, we do. But at home, we just ask, she who shall not be named, to play so-and-so radio station. And usually it's one of my stations. I'm checking on the programming, or frankly, my station that we have out in Hawaii. I really like the music selection that we do on that one. It's Star 94.3. And I'm proud to say that on all of our radio stations, every last one of them, we're using the Telos Zipstream software to both do audio processing and to encode the stream for sending off to our content distribution network. I don't know if we've got a web page we can show here. If Suncast can show, yeah, here we go. So I researched and wrote this article about getting more listeners, or at least not losing your listeners, with good audio processing for smart speakers. And one of the biggest annoyances that we found talking to people is when the level changes on a smart speaker. And, this can happen much more so than with an FM or an AM signal. Why? Well, people around the station are listening to the AM or the FM signal. You get in the car for lunch, you go drive around, you're going to make sure that the audio is all consistent. And hopefully there's somebody at the control room, at least, some of the hours of the day, and they're listening as well. Well, on the stream, you may have insertion ads that you're doing locally. You may have programming elements that you haven't vetted as well as you should. The bottom line is you may have big differences in audio level. And oh my goodness, that is annoying. So I went and talked to, Cornelius Gould. Here's his picture right here, giving us audio advice on processing for smart speakers. Also talked to Leif Clayson and got some quotes from a few other people in the industry who know about this and know what it takes to keep listeners for a long time. And I think one of the biggest things that I learned from doing this research, Mark Manolio as well. In fact, he's in the support department at the Telos Alliance. One of the biggest things that I learned was that it's important to have, over the long term, have a very consistent level. But over the short term, and really I'm talking milliseconds and seconds here. I'm not talking about 2 or 3 minutes. I'm talking about on the very, very short term, you want to have some dynamic range going on. You want to have some bebop, bebop. You want to, not have it all squeezed and compressed instant by instant, but you do want a consistent level over the long term. In fact, those two graphs on the screen right now, if you're watching, kind of demonstrate that. The left-hand graph is prior to processing. The right-hand graph is after processing. And this shows over time a strong, consistent level. Now, of course, you want your EQ to be good, right? Your bass, mid, highs. Because you're going to be coding with an audio algorithm like AAC or high efficiency AAC or maybe MP3, you don't want to cram those highs too much because that can overwork the audio encoder. You want high end when it's there, but you don't want to force it when it's not. And that'll really help the clarity and the cleanliness of the audio, especially at those lower bit rates. We also have some advice on streaming at different bit rates, but it's if you're streaming to people in their mobile devices or in their cars, you're probably not going to be able to get them at 256 kilobits per second all the time. So you want to make available a lower rate bit stream. My own stations, we do 48 kilobits It's high efficiency AAC version 2. That's HEAAC v2. And to me, that's a great codec for entertainment quality. No, I wouldn't, tune a piano on a concert with that, but it's enjoyable to listen to, certainly. And if you want to offer a higher bit rate, that's great too. The last thing to talk about is the possibility of doing adaptive rate streaming, like Apple HLS streaming, where you have a variety of bit rates and you let the consumer's device figure out which one automatically they're going to listen to. So bottom line, the folks at the Telos Alliance, I'm one of them, proud to be there and delighted to do this research and provide the tools to make your stream sound amazing. You can get our simple 3-band processor, or you can get our Omnia 9 style processing in your streams. And oh my goodness, they can sound so good. Thanks a lot to the Telos Alliance for sponsoring This Week in Radio Tech. You can go to Blog Central at telosalliance.com and find that article that I wrote about keeping your listeners with smart speakers. And of course, you ought to get you a Zipstream software, because that's what can make your stream sound really, really good with great audio processing.
And call me to get it.
and call Paul to get it. Yes. All right. Paul Kriegler is with us along with Chris Tobin. And Paul, I got a list here of things to talk about. We're going to focus our attention over here on FM radio. I want to ask this big, broad question first. I've been in radio for a long, long time, and started out in AM radio. And we know that AM radio is usually, I don't know how to say it nicely, balls to the wall, really pushing that signal out. With FM, loudness doesn't get you out farther, but it might do other good things, or it might do bad things. Here's the question, Paul. What constitutes good audio processing today for FM radio? What's the ideal processing for FM nowadays, Paul?
Well, I think part of that has to come down to whether you're talking about contemporary-based formats or gold-based formats, because the needs for each format are so different. The first question I always ask when I come in contact with a customer, it's always going to be, what's your format? So, but generally, today's needs, you need declipping in there somewhere. You need some ability to repair the damage that a lot of mastering labs are doing to today's contemporary music. And with our Omnia 9, I hear a lot of top 40 stations manage to get some, what I like to call woomph, back in the music, with some dynamics in the bass and some dynamics. Just it's a trick to do with today's contemporary music, to do that, and I hear it being done well with our Omnia 9s and the Omnia 11s too. It's just, Declipper's a big part of what I think a modern day processor needs to have, and I think we're the only company that has them. Omnia is the only line of processors that has declipping built into it. I think AES 192 is.
Oh yeah, I do want to get to that. I want to riff on the declipping just a bit more and give our listeners and viewers a bit of meat about that. We did a show, a TWiRT show with Hans von Zutphen. He invented something that he calls the perfect declipper. Actually, everybody in the company would call it that, and that's available in our products. Perfect declipper, and there's also as you mentioned, declipping in the Omnia 9 product, because as we as engineers. 11. Oh yeah, in the Omnia 11 too, the perfect declipper is available.
And the 7.
Oh my goodness, it is. Yeah. Okay. So we've seen these waveforms of what comes off of modern CDs, and I've seen these comparisons, and you can go online and look. Maybe I'll put something in the show notes, a link to an article that I'm sure Frank Foti wrote, where you look at a song from the 70s, and the audio waveform for the song is there's lots of dynamic range, and the 80s it got louder, and then in the 90s and 2000s it's just it looks it's just a square wave. It's just flat lines, top and bottom. Mm-hmm. Now,
I was a program director getting modern music from the record labels for a number of years, and it just got worse and worse and worse. And now these days, I'm hearing from a lot of country and contemporary Christian program directors that are now, dealing with this and rejecting some audio from record labels that they get sent to them, which I think good for them.
I would say, and I've said this before, and it's time to say it again, that some people ask, well, okay, Kirk, your audio processors, or Paul, the Omnia audio processors do this declipping, and some of them have this undo function to try to get rid of the hyper compression that's been done. But then you guys just compress it and clip it all over again. What's the difference? And I would say that the difference is that, well, first of all, we're doing the processing with FM in mind, because FM has particular requirements. But the other thing is, I'll toot our horn and say Cornelius Gould, Frank Foti, Leif Clayson, Hans von Zutphen, Mark Manolio, and Rob Dye, whose name you don't hear very often. These guys have listened to literally 100,000 hours of music and adjusted processing algorithms so that we can compress and clip those and not make them sound bad. And I dare say that when the record companies master these things, they're using mathematical algorithms that may or may not have a great deal of research behind them. They make that signal all clipped, but they do some damage in the process. We're able to undo, I say we, Omnia, and I'll let you speak for them, able to undo that damage and then give you a clean sound to start with, instead of having to start with something that's all mashed up. Give you a clean sound to start with and then start processing. Have I got that right? I hope so.
Yeah, when you start with something clean, it's going to sound better. Our processors are going to make them sound the absolute best that they possibly can. However, I learned at a very early age in radio what happens when audio that had been passed through the air chain and recorded either to tape or however, and then rebroadcast a second time, what sort of effect that has. And that's basically what a lot of today's radio stations are getting. It's music that's been put through a processor already and limited, and then our goal is to try to make that sound better if it's at all possible. I've heard Undo and Perfect Declipper do some pretty amazing things. They can't fix everything, but they can add just a little more room and make your station stand out that much more, especially with today's composite clippers that can pass that. And it really gives the multiband sections and the AGC sections of the processors more to work with when the peaks are attempted to be restored first.
Yeah, exactly. I know Hans has some demo of this, and I'll try to put a link in the show notes to the short video where Hans describes and shows. It shows the peaks that are restored by Perfect Declipper, and you got to know that sounds better. Chris, you are currently engineering at a jazz station. I got to believe that most jazz music is pretty well mastered anyway, and nasty tricks are not done to try to make it louder. Is that what you find, or do you find some clipping in your match?
No, I have to say the only time we run into maybe something that may be a little pop processed, if you will, is some of the more the newer upcoming artists who are have been exposed to the pop culture, if you will, of audio mastering that Paul's talking about, that we've all experienced in other formats. But for the most part, no, we've been very fortunate. We have some very pristine recordings, originals, and the audience also is very particular about it. So we keep it clean. I'm not running, a Vigilante into a Cart 6 of an Optimod 8100 into a CP803 and then cranking into the red light flashes. So no, we're good. We're just doing 2 diodes biased at the composite level to pinch it a little bit. That's about it.
I think it's important to have a box that can pull it, can keep it together when audio is being passed through it that is already densely processed. Just kind of hang out and relax, and then when it needs to jump in and keep the audio at a certain particular level, jump in. The trick is keeping it having a processor that can intelligently do both. I think that's really where we've gotten to is where DSP processing has come. We've come a long way.
Yeah, that's true, because I can tell you that our setup with the Omnia, I've got a lot of folks that call and ask exactly what are we doing, because they can't believe the way it sounds, and it's exactly as Paul, as you described it. That's what I've done. It's just, it hangs out, lets everything go the way it should. It's just loud enough so if you have the top down in the car, you can still hear what you like. And then if it gets really energetic and goes crazy, because musicians can do that, and there's nothing wrong with that, it still sounds great. So yeah, that's the approach to take. And I know in the newer boxes, you can really get crazy with that and have some fun and have some great sounds.
Yep. Paul, something that I've noticed among a lot of customers, engineers, and maybe some program directors is not everybody's looking for a box that has a lot of tweaking to do to get it to sound right. And I guess the folks at Omnia have been addressing this by providing a lot of presets. And frankly, Paul, I'm to the point where when I put a new processor on one of my radio stations, I ain't got no time to be tweaking a lot. I call up Mark Manolio and say, here's my format. What's the best preset? He tells me, well, try this one. And I'll try it. And whoa, I'm just happy. Is that what you're finding, that people don't have time for a lot of tweaking and they just want a preset that sounds great out of the box?
People just don't have time, period, anymore. Yeah, so you've got a number of presets that are still labeled format I think there's a dozen classical presets in the Omnia 11. There's even salsa and bachata presets for Spanish stations in the Omnia 11 with the latest update. So there is still some format. There's been some effort put forth to name the presets with what music this is really designed for. But there's a number of presets like Revibe and Singularity in the Omnia 11, or Plutonium or Radium in the Omnia 9, where people just don't know what they're for. And I would encourage somebody to go through the presets, try not to be in such a hurry with one of our boxes. And I'm not saying you should take a whole day to go through every preset in the box, not every preset, but spend some time. You might end up with a preset, if you listen to your program material, you might end up in using a preset that you wouldn't have thought of, using a country preset on a rock station. It all comes down to what's on the air in your market and what are you up against.
That's a good point. So, it used to be that people would call, when I was early in my career at Telos, people would call me, or they'd ask me to ask Frank, hey, send me a good preset from New York City. And when I was learning, what prints well in New York City may not sound great in Omaha because of what else is on the dial. Talk to us a little bit about that, about finding the right sound compared to your competitors.
The right sound, such a subjective thing. For me, my goal is always, if I'm adjusting if I'm driving the processor, I'm always going to try to be a little more open than the other guy, and with roughly the same amount of loudness, but have more of an open signature, tasteful amount of composite clipping. I think with the it all depends on the market and the format. It's so different, because what's going to sound good to one person is going to sound horrible to another person. What's going to sound great in one market might sound totally different. And also, what plays into this is also what's in front of the processor as far as source material, and what's after that processor. I could actually give somebody, a competitor, my preset. Not that I would do this, give them my preset and say, here you go. And it's going to sound different coming out of the radio station for a number of other reasons. There's so many tricks you can do along the way too.
Paul, something that I came across a lot, and I'd love for our listeners to at least just be aware of this. I've been to I got called to radio stations sometimes. They had just bought a new audio processor. They had bought a new Omnia processor. That's where I was working. And they bought a new Omnia processor and they put it in, and they were not happy with the sound. They said it still sounds this way or that, or it's not clean, or there's still some distortion or whatever. And so my first answer was, well, I know that unless there's a catastrophic problem with the audio processor, that's not the problem. Let's see if we can whittle down and see what the problem is. So I would go there, and what we do? We would take at the time, we'd take a CD player with an hour of their programming on a CD, as clean as could be. Or if we really had the opportunity to do this overnight, we just take a known good music CD, go to the transmitter site, plug that in directly to the processor, and we'll bring the processor out there. Sometimes they have a composite link, right? Sometimes they would have a discrete link. But either way, we would get the source material, the processor, and the transmitter all together in the same room, at least just for an hour, and put that on the air. And sometimes their eyes were just open like, wow, my station sounds fantastic. I said, yeah, we need to go find what the problem is, because it ain't the processor and it ain't the transmitter. Let's go find what the problem is. And sometimes we would find it was a bad output on the audio console, or too many distribution amps at the radio station, or they were this was still a bad composite STL, bad in one way or another, or something. And
bad capacitors in a console, in an analog console.
Yes. Exactly. Are you still, when you go deal with customers, are you still finding that you said bad source material, maybe bad source chain?
Yeah, I do find that. I find, without naming brand names, I find lossy codecs where, that's going to be the first thing I suspect. If somebody's not happy with the sound of the processor, there's a lot of other questions I'll go through related to exciter, STL, and source material questions, just trying to get to the bottom of just knowing what exactly are we dealing with here on the other end, because it's different for every radio station. Every customer you talk to, it's a different setup.
Chris, I have this impression, and maybe it's wrong, so set me straight. In a city like New York City, I guess I have this impression that maybe you guys tend to have more complicated air chains and more stuff in them, and more places where bad things can happen, whereas a small town station maybe has a simpler air chain. Chris, what's it like at your station or other stations in your area? Can you have good, clean chains that are simple?
Well, define simple, but yeah, you can still have it simple. Well, the thing is, here we'll say in New York City, the major market, everyone here has an STL, studio transmitter link, that's complicated in the sense that it's got multiple ways of getting to the transmitter site, or multiple transmitter sites getting reception from the studios. And, that's the complication level. But the good thing, today's technology with the equipment today, it's very transparent if you set it up properly. If you're a completely digital plant, if you're doing AES audio, you should be able to get transparent, clean audio from start to finish, which is the transmitter site. If you go back 20 years, even in this market, you still had pathways, connectivity for the STLs that were straightforward. Mostly the classic T1 frames that were used for most primary STLs, and then that would be backed up with most likely the audio loops of the day, the equalized lines, which had their own issues. But you'd be surprised. A lot of folks found ways to make them work as best as they can. And the state of the art back in the day, before, say, the DSP-based processors, a lot of the state of the art, masks a lot of the artifacts that you may have had, or the how would you say it, the phase rotation that could take place in various STL paths if you're using phone lines in that case. But now move forward to what we have today with DSP, and yeah, if you're not doing it right, you'll definitely hear it fast. But they're not complicated. They're straightforward for the market because of the cost of ratings, advertising. Take a market, say, outside of New York City, maybe up in upstate New York, in the Catskills. That STL will probably be very straightforward. Maybe one, if it's wireless, radio link, it'll be transmitter receiver, maybe two of them if they're lucky. If not, that's it. And the backup these days will be an internet connection. So, you have your choices. It depends on what the market will bear. And the cost and what you're willing to lose if you don't keep things on the air.
I guess I'm just in favor of simple air chains. Simplify it wherever you can, and obviously there are fewer things to go wrong and fewer things to mess up the audio, even subtly. So if you can simplify it, my goodness, certainly do that. And for stations that are going audio over IP, well, you probably do have simplification available. You're not going from a console to a distribution amp to a patch bay to something else, and finally to your processor. You may be able to keep it all in the digital domain without getting it code is not the right word, but keeping it all on the network and keeping it all in a linear fashion. And the difference I've heard myself at stations that went to an audio over IP system like Axia's Livewire, I've heard a difference, a positive difference in the audio, and the station didn't really even have a problem before that. But they sure sounded better after they went to a fully networked system. Hey, we're getting ready to take another quick break, but when we come back, Paul, talking audio processing for podcasts that a station might be doing. It's a good idea to make your content available, either best ofs or whole shows or features or winners, whether you're putting it out there on social media or making it available as full-length podcasts. You might want to have that audio processed so that it sounds good in a mobile environment or on a smart speaker. We'll be talking about that. Plus, we're talking about so many broadcast functions are being handled by computers nowadays. Is audio processing ready for this? Plenty of people are already doing it, and it may become more mainstream here in just the next 3 years or so. And finally, a real ace in the hole that people have found out about, and that is this thing called AES 192. It can make a dramatic difference in a radio station's clean coverage area. How? Well, Paul will be here to tell us about that. Right now, I want to let you know from our friends, our sponsor, Broadcasters General Store, and they feature the Henry Engineering Sportscaster. It's a sports broadcast audio control system. Now, the Sportscaster is an audio control system for managing the audio portion of a sporting event, radio or video broadcast. That's right. If you're doing video of your high school football games or even college level, you can bring the Henry Sportscaster along with you and give your talent some control, give the producer of the show, the audio producer or the overall producer, control as well, plus have a lot of built-in features. It's an integrated system, that is the Sportscaster, that includes all the essential audio functions, including audio mixing for air or webcast, headphone audio management and distribution, and off-air intercom. Yeah, intercommunications. Sportscaster is a one-box solution. It's a pretty amazing one box that brings all this stuff together. You get multiple mixers, distribution systems, headphone amps, intercoms, power supplies, and it gets rid of complicated wiring because it incorporates all these things into one box. You get, let's see, if you go over a list of what's in this one RU box, you get talent headphone audio distribution. So that's built in. Talkback intercom mic facility for the producer. So the producer can talk to the talent or even to a camera operator. It has duplex intercom between the producer and the talent. So the talent can also talk back to the producer. It's got producer headphone audio mixing, a headphone mix for a field reporter and for camera operators. Field reporter headphone output. It has duplex intercom between producer and the field reporter. You kind of get the idea here. That intercom can also be a party line style intercom. Plus, there are inputs for a crowd mic, a PA announcer. So if you have a PA announcer there, you want to bring that in, no problem. Just bring that right in. It has a Q bus for so you can audition auxiliary sources, and of course, it has a main program output to go to on-air or to streaming. Of course, all the audio levels and connectors that you might expect from a product from Henry Engineering, and it works with these these announcer pods, if you will. It plugs right into the I'm sorry, I forget the name of these pods. If anybody knows, jump in. But these are the little pods that are used. You see them on the screen if you're watching for the announcer, the color announcer, the spotter. They can mute their mic, turn their mic on and off, adjust their headphone volume, and talk back to the producer from these talent pods. Just an amazing product from Henry Engineering. And I know we're right in the middle of sports season here with football games. If you want to get ready for basketball season, or you're halfway through football and you realize, oh my goodness, our system just isn't cutting it. Well, it's not too late to get one of these delivered to your radio station so you can get it set up and put it on the air. You can have it on the air next Friday Night Football. Have it on the air for your broadcasters, your talent. And man, just be ready to go with a great sounding, workable solution to what has been a problem for literally decades out at ball games. The way to get it, contact Broadcasters General Store. You can go to their website at bgs.cc if you want to do that, bgs.cc. or give them a call. They are really good at answering the phone and being nice. The phone number is 352-622-7700. Again, that's 352-622-7700 for Broadcasters General Store. My goodness, these folks are full of great advice. I want to thank them at BGS and Hank Landsberg at Henry Engineering for sponsoring This Week in Radio Tech. All right, we're talking with Paul Kriegler. Chris Tobin is along. It's episode 416. We're talking audio processing. Paul, let's diverge for a second over to the topic of alternative delivery methods. So when stations put out podcasts, and I know Chris's station sure does, even more commercial stations are doing this too. They're taking best ofs, or maybe they do a medical show on some evening or Sunday morning, or whatever they produce locally that they want to have it available to people to download. But you know what? They're not processing it, and therefore it can sound kind of lame, and the levels can be all over the place. What is a workable solution for radio stations to easily process their podcasts?
We have a product called Radio Server that can do this. It's a product of Minnetonka Software. It can emulate the Omnia 9 X2 software. It actually doesn't emulate it; it actually uses it. So the same algorithms, the same processes involved, and so you can have much the same sound that you're used to hearing if you've got an Omnia 9 with the 9X2 software as it's used in Radio Server. So that is one solution that we have.
Yeah, this is the Audio Tool Server. And I don't mean to put in a plug here, but I guess what I was getting at in asking the question is there are offline audio processing systems where let's say that you record some show, but it's not processed, right? Your processing is in your air chain. So your show that you've recorded that you want to make available as a podcast is unprocessed, and the levels may be all over the place and not necessarily ideal. Well, you can run this through faster than real time. You can run this through a product like Audio Tool Server. You can buy that and have that on a PC at your station, or you can do this on a remote basis. In other words, upload your file. The folks at Minnetonka Audio, and there may be others too, but at Minnetonka Audio will process this exactly the way you want it, and then you download the file and you put it up for publishing. So there, we're going to have somebody on from Minnetonka in a future show, but there are a lot of great possibilities for doing this. Chris, I know there's a station in New York City, I believe it's WNYC, that produces a ton of podcasts every week, and they use. I happen to know that they use a Minnetonka product, but the point is that they process all their shows offline, and the same server preps those shows with metadata and does the encoding for different file formats, and shoves them all on the FTP site where they need to be. Chris, are you familiar with this kind of technology?
Yeah, I'm familiar with it. I've been over there and looked at it, and it was pretty cool the way they do it and how they handle it. And they do produce a lot of podcasts, so they've got a streamlined workflow, which makes total sense. And it works very well.
Okay, I haven't gotten to use it. I've seen it once, but anyway, back to Paul. So Paul, yeah, you want to deliver a consistent product to listeners, and don't forget your podcasts and other downloadables as part of that, right?
Exactly. Streaming is becoming about as important as your over the air.
So we touched briefly on this notion of so many station functions nowadays are handled by computers. So years and years ago, we started, with automation systems, right? And we ended up, in fact, for a while, we had hybrid systems. We had automation systems running CD jukeboxes and Instacart machines, or those 360
I saw a
systems.
Station, and I remember seeing a station in Little Rock that had that CD carousel system.
Yeah. Oh, I worked at several that had that, and boy, it was trouble because you'd have like 3 of these CD carousels. We had the Sony jukeboxes at some stations, and Paul, you're a program director. You know about scheduling music. Well, you couldn't schedule 2 songs back to back that were in the same CD jukebox. Now, if your station had money, you'd buy 2 copies, or you'd get 2 copies of the CD and put them in 2 different jukeboxes, and that way you could schedule them back to back, but you had to schedule the right one, in the other CD player. But then if one of your CD jukeboxes broke, oh my goodness, you were in trouble then. The library was gone. So that was a problem. But the point is, we replaced all that with PCs. And some people lament that, for the most part, it's pretty good. PCs bring their own sets of issues. But the point is, we've put all of our programming into PCs. And when we play it out, we get metadata. We know what the song is. We know how long it is. We know who the artist is. When we play a commercial, we get that metadata out, who the sponsor is, how long it was, the fact that it aired, and what time it aired. We get that. So there's a lot of benefits of putting stuff in a computer. Now, Paul, some people are putting their audio processing into a computer, and I think pirate stations are doing this first, maybe some LPFMs, but this is going to go mainstream at some point. You want to talk to us about getting away from dedicated hardware and putting our processing into PCs or virtual machines?
Yeah. So that's something that I did in 2008 by downloading Breakaway, which is the, what the Omnia 9 eventually became, Leif Kleissen's product, which I can tell you that to my ears in 2008, running that piece of software into 192 kilohertz sound card, nothing else on the radio on the market that I was in at the time, which was Tulsa, Oklahoma, nothing else sounded like that. It really stuck out, and I mean in a good way. So there's it really comes down to, are you willing to build a computer, make it as fanless as possible, with as few moving parts as possible, with a solid state drive. There's a lot to configure in the operating system. You really need a better than desktop level tech to set up the preferences upon the machine start to turn the computer into an appliance, which is basically what you need to do if you intend on using a piece of software for some sort of 24/7 appliance. In major markets where engineers lose their job if their station is off the air for more than 10 or 15 seconds, or so I've heard, a computer's just not going to cut it. If it's mission critical, there's I think folks can understandably, it's understandable why they wouldn't trust their on-air operation to a computer. Frankly, I think the best sounding processors still exist in a box.
Yeah. I got a feeling though that we're going to see a day where
Stereo Tool is a great piece of software, though. I must say Stereo Tools is a serious contender when it comes to processing on a PC.
I got to believe we're going to see a day someday where it'll be a perfectly viable solution to get similar processing to what you can buy in a box and put it in. Now, I'm not talking about a desktop PC. I'm talking about a real server type hardware where you have it backed up. You've got two copies of this thing running.
Folks are looking for reliability and they're looking for 24/7 support. And the problem that we get into, we can't really offer support on a desktop that somebody has made on their own or just bought a Dell off-the-shelf computer. We can't. There's only so much we can support.
Yeah. I know that there are some translators in Nashville, where I live, that are running various different audio processors on PC. It'll be interesting to see how it works out. I know that Omnia does offer one product, the Omnia SST, and this is a PC based audio processor for FM, and it also includes this micro MPX technology that would let you get your composite signal from wherever the processor is, presumably the studio, out to the transmitter site at a bit rate of 320 kilobits per second. By the time you add some overhead, you're at about 400 kilobits per second to the transmitter side, and that's kind of reasonable. You can do that with an IP link or even public internet. That's the same as 4 VoIP phone calls, or frankly, it's 1/10 of the bandwidth we're using right now. And you can have multiple paths with this. You can, have a main and a backup path if that's available to you. So at some point at my stations, I'm kind of looking forward to doing that. I've got some great Omnia processors now, but maybe when they start to get end of life, I'll look at doing this on server grade hardware and in a virtual machine. I don't know.
That's the real benefit of using Omnia SST right now, is trying micro MPX, which I've done here in my palatial 1-bedroom apartment in Austin, Texas. I'd send my composite baseband FM signal from one end of my apartment to the other over Wi-Fi.
If you can do it over Wi-Fi, yeah. Hey, Chris, do you have some experience with any of these systems that do in fact send composite over IP? I know they exist typically in the 2 megabit per second to 10 or 12 megabit per second range, and that's a lot. But there are some of those deployed. I'm looking forward to the ones that do it in a lot less than that, Chris.
No, I haven't. Me personally, no. I've worked with some folks who have implemented it and have looked over the shoulder and said, "Oh, that's interesting." Okay, but no, I haven't used it myself. But it does open up possibilities, and with the right imagination, you can do a lot of things with that new approach. Yeah, virtualizing your processing may be something of the future.
I've heard of broadcasters in other countries, mostly in the Middle East, in Dubai, and maybe in Saudi Arabia, where if they need a network with a gigabit per second between all the transmitter sites, it's not a money problem. They put it up, right? And so they have implemented some, and I don't remember what brands they are, but some brands of composite over IP systems, and they're using I want to say on the order of 10 or 12 megabits per second of IP to get that done. And that's not a huge bunch of bandwidth, but if you're in a rural area, if money's a problem like it is for my stations, then you want to go with a system that offers us at a lot lower bit rate. We've talked to Hans von Zutphen about this on our show before, so if you want more information on micro MPX, you can go back and revisit that. But I know for me, I'm doing live wire from my studios to the transmitter site right now at we're taking a total of almost 10 megabits per second, which is fine. It works, but I don't have a good backup plan because the public internet won't carry linear audio over IP, at least not like LiveWire or these other systems. So I'm looking forward to be able to get that bit rate way down and send that over our link that way.
It's an interesting time because the lines between processors and STLs and how our processors can interact with an exciter even by running AES 192, it's all changing.
Well, and I'm glad you mentioned the AES 192 because it seems like Omnia came out with this quite a few years ago, and where we offered. Well, hey, Paul, you weren't with the company then, but Omnia and Nautel did a project together with a digital connection that we called DSET. And I forget what that was for, digital something or other, but it was to get the composite signal basically over to the exciter. And it was exclusive, and I don't know if anybody actually ever implemented it, but it was to show that this could be done. We could put data directly into a numerically controlled oscillator, which is what these FM exciters have now, and get an extraordinarily clean signal. So a few years ago, this idea of AES 192, putting the composite into an AES digital framed signal and letting the exciter handle that. Paul, tell us about the benefits of AES 192 in the real world.
Well, there's a couple benefits. There's one, you're basically marrying the processor right to the modulator of the transmitter, so in the exciter. So you're bypassing the analog composite input of that exciter. And I'm along my broadcast travels. There's been a couple of exciters that I've come across. One of them was a Continental that I just thought sounded fantastic. It was even my favorite exciter to have in the chain. So what you get is about 15 dB more signal to noise ratio, which you can push, and yeah, most consumers aren't going to notice that or really hear that, but that's a lot you can do something with. You can make a difference in how your station sounds, and it actually causes you to process your station differently, I think, because you've got more signal to noise ratio that you can play with, and that's always a good thing. Omnia Direct, which was I never heard that it was called that. That must have been back in the early prototype days, but that's interesting. But AES 192 is a big advantage stations can take advantage of, and so is just staying digital through your whole air path. The fewer analog to digital, digital to analog, and so on and so forth conversions you can do, the better. Need to drop that in there as well.
Well, one thing that I discovered years ago, and Chris, I'm sure you've had the same thing. If you had a composite STL path, and I'm backing up to this to make a point about the AES 192. If you had a composite STL and it was noisy, right? So you got some noise coming up in the baseband, in the recovered baseband, and then you're taking this somewhat noisy baseband and plugging that into your exciter's composite input, and then you're transmitting that. Well, you're already transmitting something that's got some noise down in there. Now, we know with analog circuitry, there's always a noise floor. We don't have perfectly quiet analog circuitry, so there's a noise floor. But just to show how it does affect it, if the noise floor gets bad, well, it really affects receivers out there in the field. You just feel like you're receiving something noisy all the time, or you don't receive stereo as far out at a lower signal level as you could if it was clean. Now, Chris, am I kind of up to date so far on this? Because at one time I accidentally transmitted a really noisy composite STL, and it was not good.
Oh yeah. Well, if you did radio STLs, the classics the products that were out there, you had a signal noise floor or carried a noise floor that you had to make sure you had for the receiver and transmit link, and then you composite signal on top of that. There were many stations I worked at that we just couldn't get the RF where we needed enough of it to capture, and we had to come up with crazy ways to keep the noise floor down. And many times you wound up doing a discrete left to right just to go back out. And then the composite would be the backup. I mean, not often, but there was one or two occasions where the distance between studio and the transmitter was just beyond the range of the radio link. But today's digital stuff, as Paul points out, oh man, it's the options are, I won't say limitless, but they're definitely way more than they were 20 years ago. When 30 years ago, starting out, you had pretty much two choices: composite link that you can make work, or phone lines that you really, really conditioned. That was about it. And now you can do almost all of that if you want.
So to take that example that I had, the noisy composite STL, and as engineers, maybe you've come across this and realized the problems that it can cause on the air. Well, now let's say you've got a good analog composite signal at this point on your station, but there's still a noise floor. It may be 75, 80, 85 dB down, but there's still a noise floor down there that is getting transmitted. Well, what if by using AES 192, we get a perfect bit-for-bit copy of what the digital stereo generator in the digital processor is putting out, and we can give that perfect digital copy of the baseband signal to the modulator of the exciter. Now we're talking a noise floor that could be as low as, and Paul, maybe you've heard some better numbers, but it could be as low as down as 120 dB down, maybe even better than that, where that noise floor is. Now your exciter all of a sudden is not transmitting 20, maybe 30 dB of noise that it used to transmit. Now I realize it's way down there, and in near areas it may not make much difference, but now your whole FM signal that you're putting out of the antenna is much less noisy than it was, and this does help you out in the fringe because you're not transmitting
It makes
noise.
a big difference. I mean, the less noise you can transmit, the better your signal is going to be. Garbage in, garbage out. That'll never change.
Mm-hmm. And to your point about garbage in, garbage out, most of us with modern composite STL systems, we don't think we're transmitting garbage. But you know what? You go measure it,
You are.
and there's a limitation there, and you're transmitting some garbage. Even if you're using an analog connection, an analog composite connection. Let's say you're like my stations. I'm transmitting live wire to the transmitter site, coming out of an X node and going into my processors. Out of the X node, the noise is at like 102 dB down. The processors, when I come out of the composite of the processor, I don't know what it is down, but it's probably in the order of like 80 dB, 85 dB down, maybe 90. Point is, if I was using a digital connection between the processor and the exciter, if they could both talk that AES 192, then I get an automatic, got to be close to 20, maybe even close to 30 dB benefit of noise, lower noise.
So I'm going to name drop Alex Hartman. He was the one that was telling me about his live wire STL chain to the transmitter site and then running Omnia direct AES 192 into his Nautel exciter. He says the signal-to-noise ratio of his air chain is 132 dB. Also what comes along with that is you can hear every single detail and nuance of every mistake that had been made in the studios, somebody in the other room, in the control rooms at the radio station. Just every detail just becomes that much more prevalent. So there's... You can put that much more resolution into your transmitter. I say go for it. May not work for everybody, but to have that kind of resolution before you hit the modulator of your transmitter is, was unthinkable 10 years ago.
Hey, we are close to the end of our show, but Paul, something I forgot to warn you about, so I'm going to pop it on you now. We're going to hear from our sponsor, Lavo, and when we come back, Chris Tobin, as he always does, is going to have a tip of the week for us. And Paul, maybe between now and then, you can give us a tip of the week too. Something that you'd like for our listeners and viewers to walk away with thinking, you know what? I'm going to try that. Or next time I have a need along that line, I'm going to do what Paul said. So Paul, try to think of something like that. We're going to hear from our sponsor, Lavo, and we'll be right back with more This Week in Radio Tech. Stay tuned.
There has probably never been a better time in history to buy a new radio mixing console. Today's consoles are more sophisticated than ever, with more features and functions than you can shake a stick at. But have you noticed how complicated they are? There's a sea of knobs and switches and displays and buttons. Some of them look like you might need a pilot's license to do your show. Well, a board doesn't have to be complicated to be powerful. Just look at the new Ruby mixing surface from Lavo. The first thing you notice is how smooth and streamlined it is. Ruby has lots of cool tech, but what it doesn't have is that confusing ocean of buttons that clutter things up. Now, we all know that there are some console features the jock only uses once in a while, so why dedicate controls to them? Ruby fixes this problem by moving those once-in-a-blue-moon controls to a touch-sensitive, customizable GUI that happily shares screen space with your other studio software, helping you fight control room clutter. Thanks to this design innovation, talent that use Ruby produce smoother shows with less errors. Controls that are used the most fall naturally to hand, while functions that rarely need adjustment are easily controlled with just a couple of clicks in the context-sensitive GUI. And Ruby has cool features you won't find on other boards, like Auto Mix, an intelligent gain writing function that guarantees the perfect mix for multi-mic morning shows and call-in segments. Dual mode snapshots that instantly switch the motorized faders between on-air and production modes, and enough DSP and I/O options to make even your pro sound pals green with envy. And because quality is as important to Lavo as it is to you, every console is proudly built to fanatically precise standards at Lavo's own factory in Germany. If you're ready to declutter your control room, do yourself a favor. Check out the new Ruby and the other cool Lavo radio tech at www.lawo.com/TWiRT.
Thanks a lot to Lavo for sponsoring This Week in Radio Tech. And if you do go to their website, please make sure you add the /TWiRT to your URL, lavo.com/TWiRT. It'll take you right to the radio page and it'll let you know that we sent you. Okay, really appreciate that. All right, it's near the end of the show, but we've got two good tips for you coming up. And Chris Tobin is here with a tip of the week for us. Chris, what is it?
Well, I guess the tip of the week will be process. It's a workflow. Since Hurricane Michael has hit the southern part of the states, southeastern part, broadcasters are impacted in many ways, and it goes true for the folks in Hawaii and in other parts of the world. And I think it's time to sometimes rethink or look back or look at your broadcast continuity planning or disaster recovery, depending on what you call it, and find out, check and see if the plans you have in place are still current. Check to see if the mechanisms that are part of the plan are functional, like the generator at the transmitter, generator at the studio. And if you don't have a studio generator, so you have off-site access from maybe your air staff's homes or some other methodology, does that work? Do the laptops that you gave them for access to the automation systems, are they current? Is it Windows XP, Windows 7, Windows 10? Things of that nature. Do they have the license keys? And maybe you have production staff that works off-site and they're running Pro Tools. Do you have the iLock key? Oh, is it current? Is it with them? Or where do they keep it? Things of that sort. I know it sounds very rudimentary, but I've talked to some folks a couple of months back in my travels up north to Toronto, and we were talking about the weather changing, and snow is on its way, and it's already in some parts of the northern country. I was just talking to a friend of mine today who's now got snow on the ground. He goes, I guess there's no fall. It's just we went from summer to snow. And I was thinking, wow, some of the stories I heard about the mountaintops and sites, it gets to the point where you can't even get up there with a snowcat. So folks, just think about it. Broadcast continuity planning is very important. Transmitter site, STL links, everything. And one of the conversations, if you have multiple connections at the transmitter site, your diversity, if you will, STL diversity, make sure that those connections are coming in from physically different points of entry into your building. Because if all the telecom comes in the same conduit from the northeast corner of the building and a tree falls, that's it. You're now offline. So you may want to be thinking other methods of connectivity, maybe wireless connectivity. I think we talked about that a couple episodes back. So
sure,
give that some thought. So broadcast continuity planning is key, and I think this is the time to give it some thought. As the seasons change, both for summer to fall, fall to winter, and the hurricane season is winding down in other parts of the world. It's monsoon season.
Good points all the way around. And since a lot of us are on a budget, I like to think about what continuity planning or what backups can I basically do for free just by checking and make sure they work. Just take a little bit of my time. And then evaluate, okay, where are my weak points? And maybe one of your weak points does cost money. Well, that's when you have to ask for the money, point out to management, hey, here's a weak point. No, it's not free to duplicate this or fix it or give us a second path. But this is something that we really need to invest money in. And for a lot of stations, I can imagine that might be a lot of stations have a tower at the studio for their STL. And they usually don't have two towers for their STLs. They usually have one. And I know that some stations in the path of Hurricane Michael suffered failure of the studio STL tower. And this engineers worked very hard to get at least one or two stations back on the air using other means. And if that may be a phone line or fiber or something else different. So anyway, that the studio tower to me is one of the common points of failure. That would take a lot of stuff down. No, it sure would for our stations. Okay, thanks, Chris. Paul Kriegler, do you have a tip of the week for our listeners?
I do, especially for my major market. For our major market clients, if you've got insert points on your processor, use those for your PPM encoding. It makes a big difference for the PPM encoders that Nielsen gives out to see a nice consistent level. Use insert points or split your processing where you've got dynamics being handled and then you've got your encoder in the middle and the rest of your processing chain after that. That's another good way to handle it. But either split your processing or use a side chain in a processor to do your PPM encoding. That's my tip.
That is a great tip. That is, and so many processors now are, especially those from Omnia, are made with that in mind. Exactly. We've actually, Corny Gould has done a lot of research into that to find out what functions should we handle prior to the PPM encoding and what functions need to be saved for after the PPM encoding. So we get the minimum sound on the air, if any, and make sure those PPM codes are in there. So thanks a lot. Appreciate that. All right. We've had a lot of great tips and talk about audio processing for on-air use. That's very key. And also for podcasting and for streaming and smart speakers and all that. And the incredible benefits of using an all-digital path like AES 192. So, Paul, thanks for the updates on that. And understand. Oh, wait, you're the guy that goes out in that van, that funky big gray van.
I'll see you in Wisconsin, Kirk. I'll see you next week.
Are you driving the van up there?
Yeah, I'm driving the van. The van is in Milwaukee for the weekend because I'm here in Austin, and don't tell anybody, but I'm going to Austin City Limits Music Festival this weekend. But I'll be back in the van Monday, and we'll be in Madison for the Wisconsin for the engineers sessions and for the Wisconsin Public. What's the Wisconsin WBA? Thank you.
The Broadcasters Clinic, and Chris is going to be there too. And you know what upsets me is that I got to leave like the first day after Alex and I give our presentation. I'm there for a while, and then I got to drive back to Milwaukee. But maybe we could all have lunch together and something together. The three of us while we're up there. Chris, you're going to be there, right?
Yep, I arrive Monday. I have to fly out very early Wednesday morning. I guess originally it was for AES, but that got moved to Thursday. So yeah.
Yeah, that was me too. I'm flying out of Milwaukee, in and out of Milwaukee, and driving to Madison because the airline rates were just crazy high going to Madison. United and Delta, you ought to think about that. I avoided you because of that. So,
and you assume that they care?
Nah, they don't care. Don't care a bit. But Southwest is getting more of my money, as they always do. So there you go. All right, guys, we will see you. Thanks a lot to Paul Kriegler with the Telos Alliance. He is the U.S. audio radio Omnia. It's a long title. If you want processing in the U.S., you talk to Paul. He's going to take care of you. And Chris Tobin's been with us. Chris, you do all kinds of consulting and engineer for WBGO. So thank you for being with us. All right. Thanks to Suncast for producing today's show. And to Andrew Zarian, the founder of the GFQ Network. We sure appreciate being on it. Also, thanks to our sponsors. Please patronize them. It does help us, and let them know you heard about it here at TWiRT. Next week, we're going to be broadcasting live from somewhere in New York, either the AES convention itself, or we're going to be at the bar we were at last year, Rattle and Hum. So that's, or maybe we'll do both. Maybe they'll stick me at AES and Chris Tobin will be remote at Rattle and Hum. Who knows? But we're going to be together and have a great time. So stay tuned for that. Chris, I've got a new audio mixer for us, and it works. I've got the IP tablet and an Axia X Node, and that's our mixer.
Excellent. I look forward to it. This is fun.
Well,
this is good.
I got to test it good. So I'm going to bring it back up, but I got to test it, but I think it's good.
All right. So maybe we do Rattle and Hum and go fun, have some fun.
I think we should hum and rattle. Yeah, I think we should. All right. Take care, guys. Hey, tell your friends about This Week in Radio Tech. Thanks for watching. We'll see you next week on This Week in Radio Tech. Bye-bye.